So you have the whole class for yourself today. Okay, great, great. All right, so let's start. Last time we were talking about HBase, right? We were here. We talked about the MapReduce on HBase, and we also talked about the REST interface. Okay, so REST interface is generally of this format. This is the general URL definition. It starts with a scheme. It could be HTTP, it could be HTTPS, user colon password at the domain, at the basically user info at host name, and then 8080 is the port. Afterwards, this is the path to the resource which you are trying to access. Hi Santosh. All right. Now, after that, there are parameters and all that. Okay. So URL and parameters, and afterwards there is a fragment. This fragment doesn't generally go till the server. This is only the browser side. So this is the standard format of the URL. Now, in case you want to access your HBase on a particular port, either you can say HBase daemon start, or you could specifically say start REST at this port. Okay, let me start my. The benefit of the REST interface is that you don't need any special driver to talk to your server. And the other on top of it, the benefit of REST interface is that if it is properly done, then you can basically if it is properly done, then we can basically call the server from the browser itself, meaning from one website which want to present the data, we can call our HBase. Okay, you can call our HBase from there. Alright, so now we have started the HBase REST interface using HBase REST start at some port, and once that is done, we can start calling the URL. Okay, so for example, if so we have not talked yet about HBase shell, or did we talk about HBase shell last time? So HBase shell is the interactive interface. Using list, you can see what are the tables available. So it says it looks like the region servers are down. Yeah. It says the connection loss for HBase ID. Looks like Zookeeper says that unable to set watcher on the Z node. And the okay, so let's just see what's the status. So none of the user region servers are up. because I restarted the machine. And before that, I think we should start the HBase master, or we can say start. Alright, so it says HBase master starting. Okay, okay. I'm just hoping that this is done. Let me just start the actions, all host, region servers, start. So do you remember what was region servers? Region servers were the one there which are actually going to store the data. Now all the region servers are up. Now you can quickly start the HBase shell. Correct, correct. So we can see the list of all the HBase. Yeah. And a better thing would be to actually take this interface to somewhere at the end. All right. Oh, it is again stopping. Maybe I need to fine tune the memory. Or maybe I need to move this edge base to somewhere else. Because Hadoop 1 is actually overloaded. You see name node is there, full. Hive server is there. Data node is also there. And so these two are very intensive process which consume enough amount of RAM. Alright, so let's see if something is working. Shutting down again and again. Hi Chandra. So actually lot of people are at leave today. So okay, okay. All right. Oh, actually I'm doing very big mistake. Um, I'm trying to connect from the my local machine, thinking that I'm on Hadoop one. I had installed the HBase long back on my local machine, only the client. But anyway, the master is not coming up right away for some reasons. Let's say the HBase master has gone down. Actually, this machine, either I need to move it to somewhere else. Looks like the no Hadoop one looks like overloaded. I need to diagnose this. Never mind. So, all right. The general command is that you go to HBase shell, type, check the status of HBase, if everything is running fine. And if it's everything is running fine, then you can create a database like this. Create a table, and you can define a column family. Create my table with this column family, and then list down. You can also see by whether your table is created or not by listing it down. Also also you can specify a regular expression. If you want to create some value into my table, you generally specify table name at the first one, then the row ID, and then the column name, and then the value. And notice that the column name includes the column family. Okay. Okay, so it says can't get master address from the zookeeper node. So zookeeper node is down, as you can see clearly. Even the master node doesn't have anything. All right, so we'll actually do a demo once my servers are up. So till then, maybe if you have a virtual machine, you can try it out. All right, and scan table basically does something like, so scan table basically scans the table. It goes through the list of the it goes through the whole table and prints out all the rows. If you are interested in only one row of this table, you say get, or your specific cell you are interested is get my table and row ID and the column name. So it will print out 1, 2, 3 with the various timestamp information. Okay. You can also say describe my table, and if you want to delete a table, you can say disable and then delete. All right. Uh, but RAM is fairly free. Still, there's some other issue. I need to debug this HBase problem. Right now, it's not running on the server. So till and we can give it a demo on the next session, which is tomorrow. So no worries. Or if you have a virtual machine, you can try it out right away. And y- okay, so to see the status, you can go to the URL, and at this port, it runs the web interface for showing the status of HBase. All right. So this was for little demo here. And the REST interface we talked about is this is how generally the URL looks like. And path is the one you need to specify all your information in. So you can specify in the path saying, starting from the slash, you can have a table name. After that, you can have the row ID, and the brackets say that it can be 0 or more, just like a regular expression. So this grammar says that you have to specify a table followed by a row, and having the column and the column family and the column name is optional. Okay. And for I mean you can keep on specifying any column you want. Also further, you can specify the timestamp. So the format is table name, row name, column name, after that the timestamp. All right. So that is for getting, and say similar is for putting. So when you are making a query of get, then it's basically normal HTTP get. If you are putting, then it's a HTTP put request. All right. Now this is all right. And we also told that in case you want to connect to HBase via JDBC, you can use a driver like Phoenix. Just that because SQL interface expects the tables to be declared upfront so that the mappings can be created. You will have to define the tables using Phoenix before you start. If you look at a quick instruction, you will understand that. So as part of the, you can see here, and in the driver manager, there is a nice document using quick start. Okay. So basically you'll have to create the table name properly, and then you can start using HBase. All right. So yeah, so there was one very important concept which we missed last time, that is Bloom filter. Is anybody aware of what is Bloom filter? All right. So in the systems, in a heavy load systems where there are too many requests for looking up for a particular ID, or when our search systems are too much overloaded, then we need to delegate some of the search load to somebody else. So Bloom filter makes it possible to do that. All right. By creating a server which acts like a filter and another service stays as is. Now, the question is, how does it really work? Imagine that there was this main server to which all the requests were coming from the user. Okay. There were main server to which all the requests were coming for looking up for an ID. Every request comes in and asks, does this ID exist? Does this row ID exist? And it says no, it doesn't exist, or yes, it does exist. All right. When the server got loaded, this storage server, when it became very overloaded, it thought that it can delegate. So basically, to delegate some of the load to another one, what we do is we create a Bloom filter here. And how does it work is the user comes to Bloom filter. Bloom filter does a quick check in the memory, and in case it says that, oh, this user exists in this quick check, then it goes for real checking. Okay. Then it goes for real checking. Otherwise, if it doesn't exist, it replies that it doesn't exist. Okay. So you can say that Bloom filter knows for sure that something doesn't exist, a key does not exist, but it does not know for sure. It does not know for sure that something really exists. For example, if this Bloom filter was only given first two letters of all the keys, okay, out of a billion keys, how many would be the say how many total possible strings are there out of two characters? So there are 1 billion strings, 1 billion string IDs. So, okay, before we talk about Bloom filter, I would like to tell you this also, that Bloom filter is not only valid for HBase, but Bloom filter is a general computing concept which is used at a lot of places. Okay, so imagine that HBase has 1 billion row IDs that are string and are let's for argument's sake they are alphanumeric for time being. Okay, so question is, if we just give two characters of each string to the filter, how how many such combinations are possible? How many two how many maximum two letter I mean two character IDs are possible? Yes. So AA, AB, AC, AD, and so on. Yeah. So how many would there be? And then we'll have BA, BB, BB, and so on up to then CA, like that. So how many do you think this list will be? How big this list should be? So basically, we had one big storage containing a billion IDs. We just took first two letters and told this filter that you just keep these two letters IDs, and whenever comes you do this first checking, rudimentary checking with the first two letters of the name. If that matches, then send us for the real confirmation. Otherwise, just say no. Okay, so my question is that the filter will receive two letter words, two letter IDs. How many unique would be there? And let's imagine for time being, it's alphanumeric only. Before that, there'll be A0, A1, and so on. Similarly here, it'll be B0, B1. Murugan, are you with me? Chandra? Sham? Santosh? Yeah. So my question to you is, out of 1 billion string IDs of rows, what we did was we just took first two letters of each. So how many maximum unique unique two character IDs are possible? So those IDs, basically we are just taking two characters from about 1000, which means 1000. Anybody else? Basically, we're preparing a list like this. How many maximum unique two character IDs are possible? Two character alphanumeric, okay? Alpha. numeric IDs are possible. Chandra says 1000. And Murugan, what's your opinion? 1560. Good. So how did you let me also compute? So it will be 36 into 36. All right. So 26 plus 10 and 26 plus 10. So first letter will be A to 0 to Z. That will be 26 plus 10, which is 36. 36 into 36 is 1300. Now, out of a billion strings, we have broken it down, brought the total number of strings to 1296. Okay, so this system can basically keep all these 1296 IDs into the memory and check a lot of things, finish checking lot of things here itself. So uh, lot of false request, meaning lot of request which does not have the valid ID will go back from the filter itself. Okay, go back from the filter itself. Only few will hit this one. So you notice that the correct ones are being checked twice. First by the filter, second by the real one. Okay, in case a key does not exist, in case key does not matches the first filter, which is first two letters are not with the here, not matching here, that means it's for sure that it does not matches at all. It does not match at all. Therefore, it says no right away. In case it exists with a filter, then it sends it further for the checking. Okay, make sense to you? So he in this example, for simplicity reasons, we just prepared the IDs on the first level by first two letters of this ID. Instead, what people do is they create the hash code, a small number out of each string. Okay, and that makes it possible to to a very large extent filter user from here itself. All right, this is called Bloom filter. Okay, when you want to check for sure that something does not exist quickly, then a Bloom filter comes very handy. Also, if you notice that it actually, right, false positive is something which right now looks positive. Okay, so yeah, here this has to be yes. Okay, this has to be yes, only then it reaches till here. Okay, so okay, what happens is there is a one key one, asks the filter says no, it does not exist. Filter itself just compared, say, in our rudimentary example, let's say filter is just checking for first two letters. It says no, key one does not exist. Or there's some other filter which is just checking for the last two keys and last two letters. So when the key comes to Bloom filter, it says that it doesn't exist with me. So if something doesn't exist with a filter, it is for sure does not exist in the storage. Okay. In case it exists, in case it exists here with the filter, meaning as per the filter's records, this key is matching. In those cases, the request goes further till the storage. And now storage can say yes or storage can say no. Okay. This is false positive because although the key is not really existing in the main storage, but as per the filter, it is existing. All right. So the filter can have multiple kind of basically there is a huge register. In imagine a very huge register. Opening that register and finding some name is too costly an affair. Therefore you try to create a very small register which has only partial information about what is there in the register. And partial information could be in the form of hash code, IDs. You generate hash code of all the IDs, and total number of hash code generated may be 10,000. And you just match with the 10,000 records here in the filter, and delegate the searching work to some other filter. That is the whole idea. Right. For example, if the key is AA and the matching can be yes. So if basically the filter our filters logic is that we are checking only first two letters. Filters logic could be that just sum up all the letters and divide by 26. Okay. And that should also give you a very good number. Okay. So creating a hash value such that it has the minimum number of false positives. Minimum number of false positive meaning unnecessary disk access should be low. Because what happened here in the first case, the key did not match at filter level, so it was thrown away. In the second case, key matched in the filter level, and then it goes to the real storage. And real storage, the real storage also checked it and said yes, it exists. Yes. And in the third case, filter says yes, and when it goes to the real storage, it says no. So the idea is to reduce total number of false positives by improving your filter. Okay, by improving your filter. So a filter can actually work by keeping its, the keys. There will be a set of keys, say hash code or first two letters. All of those Bloom filter level keys, they need to be, if they are loaded into the memory, it's very fast to check in the memory. Okay. So this is the general idea about Bloom filter. Make sense, Chandra, Morgan, Santosh, and Shyam? Yeah. Any questions to me? Is Santosh around? I think he's logged in from the web, so I'm not sure. All right, so okay, makes sense to you? Now there is something called a coprocessor. So Shyam's question is, so do you define it along with the table? So generally, basically in the case of HBase, it will be on the same machine or it can be on different machines. All right. And yeah, his question is, do you define along with the table? So we do not define. This is here. the filter is entirely taken care by the HBase. HBase takes care of the entire Bloom filter by itself. Okay, we have generally no intervention whatsoever when it comes to HBase's Bloom filter. Okay, now you might ask, then why are we discussing it? We are discussing it because it's an important topic which people ask in the interviews, and also when you're implementing things in other languages, also, this will come very, very handy. Okay, this will come very handy. Now, similar to our database's triggers, there is something called coprocessors. Coprocessors makes it possible to create code that is executed on HBase server side, and that is also divided amongst multiple machines. Okay. So basically we can write coprocessors for various kinds of things, such as access control of a cell. When people come, if you put a trigger before the get access of a cell, then your coprocessor is accessed before the data is accessed from the HBase, and that can be used for security reasons, for enforcing a further levels of security. You can use coprocessor like this, or you can say that on the data changes execute this program. Okay, those kind of things can be very handy. All right, the general idea is that you create a class like this. After you have created a class, you export the jar just like we did for pig UDF and hive UDF. Take it to the region server, update your hbase site.xml, and here you might have to restart hbase. But in case you don't want to restart the hbase, you can load from the table attribute. Okay, you can basically say that your file basically you define a path and you put this file, this one, where is this? So once you have uploaded this file, I'll show you. So we basically create a table descriptor containing the table name, created the family, set the value, here. So we basically set the value in one of the tables that this is my coprocessors. The important part is, so here we define the coprocessor that whenever user access something, execute my function. We defined a class which says that whenever user is trying to access something, execute this. Okay, and we defined the real logic here. One was that we could have defined the logic inside XML. In that case, you would have to restart HBase. But in case you want to keep it dynamic, what you do is, after creating the table, what you do is you define a attribute called coprocessor $1. Okay, this is the strong key basically. And once it is done, you give it the real path from HDFS, that here is the location of our class, our logic, which should be executed, at as a coprocessor. Okay, it should be executed as coprocessor, and that gets executed. All right. So that's pretty much about HBase. We should have given you a demo, but we'll give the demo maybe tomorrow. All right. So should we move ahead? All right. So we want to discuss something called Zookeeper. We had been talking about Zookeeper for quite some time. Yes. Okay. So here is the assignment. Yeah, I think that is better idea. So HBase's assignment is little different. Did you try, Morgan? So Shyam's question is, which is most commonly used NoSQL DB? As per my understanding, it is either Cassandra or Mongo. I think it's Cassandra. But HBase comes very, very handy. So if you consider by the number of installations, people might be using HBase as a maximum number of instances. And independent cases when they don't want HDFS, Hadoop, or anything. In those cases, people either go for a database like Cassandra or MongoDB. All right, so let's talk a little more about the assignment. Okay, so there is this big question which says, if you have to design a simple Gmail-like email storage and you have to store data in HBase, what will be the tables? What will be the row key, column families, column under each family for each of the tables? All right. So I'm going through Murugan's answer. He says that the table will be users and mails. Okay. Users table will have row key as user ID and column family would be username column family. Or you guys want to give it a try and discuss later? Yeah? You want to give it a try and then discuss it later? Or you want? All right. So Murugan, let's discuss a little later and and I think it will be unfair on our part to, yeah. All right. So just to give it a try, what when Chandra and Santosh and Sham, give it a try. Whatever scheme you come up with, and it should be fine. Okay. All right. Yeah, that's correct. Uh, Yeah. So yeah, I'll respond to your answers separately. Okay. So for quite some time, we have been talking about something called zookeeper, and we haven't really described it yet. Now, in very simple word, zookeeper is a distributed coordination service for applications which themselves are distributed. All right. Now, zookeeper essentially exposes a set of primitives. It's very easy to program to it and uses a data model like directory tree. Okay, so most of you may not be able to understand what does it mean by coordination service, but let me give you an example. So whenever there are group of people and they want to coordinate on little while, for example, there are bunch of crawlers. You are running crawling service on multiple machines. Crawling service as in these are downloading the data from various websites. Now, these downloaders need to coordinate with each other such that they do not start downloading from the same server. Okay. They do not start downloading from the same server at the same time. So one way is that we send only one URL to only one machine which will be crawling it. But lot of time it's not really possible to pre-plan this kind of coordination. So instead of that, what happens is each of the node who is downloading something will go to a central place and mark that I am downloading this thing. Okay. And before it says that I'm downloading this, it first checks whether somebody else is downloading the same thing. If nobody else is downloading the same thing, it creates the information there saying I am downloading it, so nobody touches it. Okay. So it's like a coordination service. It's like if you remember the sales calls, people used to coordinate with each other. If all the salespeople are in the same room and making calls, they will coordinate with each other by writing it on the whiteboard so that others can see it quickly. Make sense? So that is coordination service. The coordination service should be so strong in parallelism that it can it can handle multiple threads, multiple calls at the same time. Also, a coordination service has to be very, very consistent, while a coordination service does not need to store too much of data. It's only few variables that are stored in a coordination service. All right. So, the duty of a coordination service like Zookeeper is that it should provide coordination between various people, and various people can coordinate only if the announcement of one is audible to another. Okay. Okay. So you might question that if it is so consistent, it is so good at all of this, then who is stopping us from making it the NoSQL, right? The The truth is, it is not supposed to store more than few kilobytes of information. Now, it provides you a shared hierarchy space like file system. So for all the systems who want to coordinate with each other, they will look at Zookeeper like as if Zookeeper is just a file system, and they will keep on writing to this file system and reading from this file system. There are few differences from a hierarchical namespace like file system. This namespace has each folder is called Z nodes. The each node in this tree of a hierarchical namespace is called Z node or Z node. Some people call it that way. Okay. The most of this data is kept in memory to achieve really fast turnaround time and high throughput and low latency. And I mean the axis is string is strongly ordered, meaning it is heavily synchronized. Multiple threads, multiple processes, multiple machines, all talking to same machine. It's just okay with Zookeeper. Okay. Also, Zookeeper itself is a highly available service. Highly available service. The client keeps a TCP connection as soon as something. So here is the client, and there are multiple servers. Okay, there are these are the clients, and there are multiple servers. Just a second. So this is how the Zookeeper looks like. Ha, all the clients are having one TCP connection to the servers, and they keep on client keep on heartbeats to the server telling that client is alive. And if client does not give the heartbeats to the servers, server thinks that client has got disconnected, right? And yeah, clients are really smart in this case. Okay, now these servers know each other. These servers know each other very well, in the sense that there is, okay, they keep in memory state. We'll talk about how does this whole server thing works. And okay, so here it's highly available, and I'll give you the brief that out of these servers there is one writer. Let's say this one is a writer, all of them are reader. Okay, and they themselves, amongst them, these servers, they themselves vote for somebody, okay, to make somebody the master, which accepts the write request, and rest will be for reading the data. So one machine is the writer and rest of the machines are reader. All right. And this selection of reader, or a selection of the writer is called master. I mean leader. Selection is called this. The one on which we write the data is called leader, and rest of the nodes are called followers. The selection of the leaders by the followers or by all node is done based on the various response times of the server. In case one particular leader does not respond properly or is shut down for some time, immediately the election happens and other node nominate some particular node as the leader. Okay, that is the whole mechanism of Zookeeper. Zookeeper makes to make it really well synchronized, it stamps each update with a number. The number reflects number of order of transactions so far. And yeah, it is fairly fast. Zookeeper is really fast in the sense that the reads are when the reads are more common, it performs best when reads are more common, like with any database. Okay. So at Yahoo, it was clocked, it was benchmarked at around 10,000 operation per second for write dominant workloads. Okay. So a quick one, you can just after logging in right now, the reason none of the region servers is actually up. Zookeeper server is up. It's just the region servers are down. So we can say Zookeeper client and it says status, or you can say you can basically talk to this server, to talk to this local service called here and ask, are you okay? It says I'm okay. And in case I want, all right. So basically, the Zookeeper itself is a good service to which you can basically connect to a port and issue multiple commands. Okay, just to check whether it's working fine or not. All right. So these are the general administrative four-letter command which give you quick response, showing you various kinds of details. Okay, these are administrative commands. Now, to get started, you can just download Zookeeper and say server start. This is for single node one, while the multi-node installation is little more tricky. Okay. In multiple node installation, you have to take Zookeeper, install on all machines, and then configure the server telling about each other. Okay. So the data model looks like this. Data model as in when you will be storing the data. Yeah, it is something like an index server, you can call it. So you can, the data model looks like this. There is at the top, there is root folder, under which there is another folder, or we can call them Z nodes. And under each of them, there are further nodes. Okay. So a Z node can have children and Z node can have data, unlike our normal Windows folder. The way inside folder only we can have the data, while here everything is a folder and everything is a file. The smallest unit is the Z node, which can store information and can have children. Okay. So the data access is that either you read the whole data about from the each node or you read nothing. Okay. And you cannot append to the node or you cannot do partial updation. You have to update the full node. Now, these Z node which we talk about, these Z nodes are also of two types. One is ephemeral. Ephemeral are something very interesting. When a client connects, it creates ephemeral nodes. And the moment client get disconnected, these ephemeral nodes created by the clients disappear. In case the client creates in case the client creates the persistent nodes, then those nodes do not disappear even after the client disconnect. Now you may ask, what is the point of ephemeral node, right? So ephemeral nodes are probably most important thing out of the whole zookeeper. How? So in our case, there was HBase, there were reason server. HBase was trying to find out about its the reason servers, right? So all the reason servers will, as soon as they come up, they inform Zookeeper about that I'm up. All of these reason servers are the clients. They inform Zookeeper by the way of each region server informs Zookeeper by the way of Node. In a folder, it will basically create in a folder it will be basically create another folder of its name. Or in another word, under a particular znode, each region server as soon as they come up, as soon as they are started, they go to Zookeeper, find out the Z nodes in which they aren't supposed to mention their name, and create an ephemeral node with their name. In case this ephemeral node disappear, we assume that this node must have gone down. All right. So I'm just trying to create whether. All right. So it looks like Zookeeper is working fine. Now, the way we communicate with Zookeeper is by creating these folders or getting the data from one of the folder or znodes. So let's say we want to create a sequential node. So let's first talk about normal node. So this structure the structure we talked about is something of this sort. Meaning, if you say ls slash, we get say zoo. Okay, we can keep on going down. Then there is these are the folders. Similarly, we can go back to ls and say ls slash sg. So these are the nodes you see. Okay. So all I did was from the command prompt, I said zookeeper dash client, and this is what started. And now in case I have to create something here, I can create either an ephemeral node. Ephemeral node is something like create minus e and something. Okay. If I want to create something called a sequential node under SG, I can create a sequential node. Okay. So I can say create minus sequential node under SG with the value as something like this. Now you keep on creating it again and again. Every time there is a new sequence number being generated, right? Now if you say s slash sg, all of these nodes are created under this. ls for listing the node under a particular folder. If you say ls slash, it gives you the uh, total number of nodes. And if you notice that if you notice that Hadoop is also having folders here. So you can say hbase unsecure is here. I can say ls slash hbase unsecure, and under hbase unsecure there will be other folders such as there will be region servers, meta region servers, backup masters, region in translation, and namespace and rs. Okay. Okay, so there are no rs right now, no region servers. And so hbase also talks to zookeeper the way we are talking and try to get the folder containing all the zookeeper region servers available as of today. Okay, so it's a central place from which can be utilized in any service. Okay, so for each G node, the sub Z node are created sequentially if you specify a parameter like -s. Other than that, when you create a node, you can also specify that let me specify something called a watch. We can say that trigger this once something happens here. Just that these watches are only for once. Just like JavaScript triggers, they are also triggered only once. If you want to trigger multiple times, register another watch in the event notification. Once you received the trigger of the first one, then you register for the second one. Okay, for the recurring event. The watches are okay. Now the various command which I was trying to show you, for one of these commands is create. Create basically creates a Z node. So the way we create a Z node is we say create and we say my node, and then we specify some value. This is my some value. This is the value of the node, the metadata which we are adding at every node. Okay. Now you can see that if we say ls slash this, you will see my node is here. Okay. We can also delete a node. We can also check it. We can also get the access control of a particular node. We can get the children of a particular node. Okay. To get the data of a particular node, we can simply say get here and it'll give us this detailed data of this node. Okay. Now you can see that slash sg has got data called asgiri. Alright. Okay. It basically batches together the multiple operations. Alright. So this was how we talked to Zookeeper. And as part of the data model or the API model of Zookeeper, all of these operations create, ls, update, all of they can be combined together in a single batch. With respect to API, there are multiple clients available. There are two core which are Java API client and C API client, and rest of them are contributed by people like Perl, Python, and REST. All of them are contributed by people, and basically the main philosophy with any API of Zookeeper is that for each function there has to be two kinds of API controls. One will be synchronous, other will be asynchronous. Meaning, if you call if you call the asynchronous function, then you don't need to wait till the function returns. The function returns very quickly. It's just that you provide a handle to a function, to a callback. You say that please execute this function when the call is done. That is asynchronous. Synchronous is you call the function in traditional manner, you wait for the result to come, it will make you wait for result to come, and only then you can move ahead. All right. Also, while getting data, updating data, we can specify the triggers. Triggers are something which are executed, or which are your piece of code which will get executed whenever some event happened. For example, the watches created by the way of exist function get triggered when a z node is created, deleted, or we update the data. Similarly, while getting the data, we can specify triggers. These triggers will be executed when the Z node is deleted or its data is updated. Okay. So similarly, the children will, if you specify the trigger as part of get children function when you are getting children of a particular node, then that trigger will execute when any of the children is created or deleted. Okay. So ACL is access control list. It provides a finer control because when you are building a coordination service, you may not want people to be disturbing your service. The way we just said, we just looked into what is HBase doing, other people might also damage your service. That is why, that is why Zookeeper handles takes care of it by the way of ACL, so that multiple application, multiple users can use Zookeeper correct safely. Okay. So the authentication, there are three kinds of authentication: digest, SSL, and IP address. While an ACL is a combination of authentication plus authorization. Okay. Authentication and authorization. All right. So in real life, Zookeeper is always run on a cluster. It is never run on a single machine. Standalone server is only good for testing. It's not good for anything else. Okay. A little bit about architecture. The architecture resembles a lot with systems with MongoDB, or the architecture resembles a lot with something called the gossip protocol. The gossip protocol is the standard mechanism which makes a service very highly available. It goes like this. You created Zookeeper out of 5 machines. Let us say these 5 machines will elect a single member called the leader. And once they elect this leader, all of them will be called followers. There will be one leader, others are followers. Now, as soon as you designate a node as followers, all the nodes synchronize their state with what is the state of the leader. Okay. So when these machines are designated a leader, they synchronize their states from the leader. And once that is done, our system is up and running. In case one of the node goes down, or the leader fails to provide, in case leader goes down or leader fails to provide a feedback appropriately, leader has to step down very quickly, and there is a quick election again within 200 milliseconds. So this is the exact same architecture used in other systems like MongoDB also. Okay, so what is the difference between this and HBase or HDFS? This architecture, how is this architecture different from HDFS? Quickly, somebody. What's the similarity? Similarity is Zookeeper has a master, HBase has the master, and similarly HDFS has the master. So what's the difference between this architecture and that architecture? Perfect, perfect. So in this one, the leader immediately gets replaced by somebody else. All right. That way, that is why these systems are called highly available. All right. And exactly same way, it makes it possible for others to have a relatively highly available service. So now, once the leader has been selected, the second phase is the atomic broadcast. All write requests are followed to or forwarded to the leader. Leader's main duty is to provide the writes. The clients, the users will, whenever they write, they only write to the machine which is running as leader. Okay, that is why, because there has to be single leader, and single leader who can only provide the rights. Others cannot provide the rights, while the leader might occasionally provide reads. Okay, but others cannot provide the rights, only the leader provides. Why? Because because the data has to be consistent. If there are two leaders, sometimes one row you are writing to one, and you are updating the same row in another, then you are deleting on another machine. Now if there are these three set of information, which one is the truth? Okay, so it becomes heavily inconsistent the moment we have so many more than one writers. Okay, therefore even in MongoDB or any other system which follow this gossip protocol, there is always one master which lets you write the data, while there are all the other nodes which gives you the ability of reading only. Perfect. So as soon as the data is written to the leader broadcasts the update to all the followers, and when majority saves the data, the leader says that the commit has happened. Okay, when more than 50% node saves that information, then we say that commits has been finished, and it gives the success response to the client. Okay, and also note that these machines write to the disk before writing to the in memory. All right. Again, same way, a leader is selected, all write requests are being forwarded to the leader, and read requests are being served by all the machines. Now, a question to all of you. Are you with me on this selection? So, there is one tiny detail in the selection of the leader. If you had defined that there are three machines in your, what do you call this? There is a very good name. There's the it's called, there is a master, there is a leader, there is follower, and all of these servers together are called ensemble. These are called ensemble. Okay, so these are called ensemble. This is our ensemble. Okay, now now the important thing you should note here is these machines are ensemble. If more than 50% of the machines are not voting, then there will be no leader. If out of 10 nodes, if out of 10 nodes, if if 6 voted, then there will be a leader selection. If only 5 voted, there will be no leader. In this democracy, that is the rule. Okay? Out of 10 nodes, at least 6 have to vote. In case 6 people are not available for voting, nobody becomes the master, and nobody becomes the leader, and everybody is just read only. The whole zookeeper will stay read only if there is no master, no leader. Then, and the leader can only be selected if there are 50% voters available to vote. If your machines are going down, it can tolerate, if there are n number of machines, it can tolerate up to n minus 2 minus by minus 1, those many machines. Or if there are say 10 machines, as long as 6 machines are available minimum, they can select a leader. The moment the total number of alive machines are 5, then the then there'll be no leader, and the whole zookeeper will be read only. Now here is the most important part. So we had A, B, and C, 3 machines. A was the leader, and for some reason A got shut down. What will happen? So how many are available after this? B and C, which is 2 out of 3 are available, which is more than 50% or less than 50%, right? Which means that there will be an election of the leader. So B or C, either of them, based on which one is performing better, will become the leader. Now, in the next diagram, if A got shut down as well as B got shut down, then what will happen? There is only 1 out of 3 available. Then will C become the leader? C was the leader. In A, B, and C, C was the leader, but B got shut down. There is only one machine called leader. So what will happen? So Morgan says that there will be no election. Okay. Does that mean C will remain the leader? Yes. Sham is right. There will be no rights. Leader will step down because in this democracy, less than 50% people are available. So Noble will become the leader. C will become the follower. C will become the follower, and majority is not available. Okay. C will step down from, yeah. Yeah, we should share the same model. Correct. All right. Yes, Santosh, are you okay now? Slide number 25. Yeah. Slide number 25. You can see the here what I have tried to demonstrate is if A and B and C are there, leader shuts down, then somebody else becomes the leader. Either it could be B or it could be C. right? Okay, so the way it is generally decided is based on the ping response time. They all ping to one of the nodes. Whosoever is responding best gets the maximum number of votes. All right. Now, no one becomes the leader here. Does it sound reasonable to you, or does it sound plain stupid to you? Ideally, we had been living with a single server. Why couldn't we continue to run the single server? All right. Now let's have a look at the diagram. So the question is, even though we have 5 machines out of 10 available, still the whole thing shuts down and the whole thing becomes read only. I mean, there is no writer, so the writer system will shut down. Okay, does it sound unreasonable to you? Does it make any sense to you? Do you, or in my in another words, this 50% votes, why do we have 50% minimum, more than 50%? Why is that criteria? Why the design has been this way, that in case there are less than 50% votes, then less than or equal to 50% vote, the leader steps down. There are no more writers. So why is that? Do you find a reason for that? Anyone? Question is, let's say we have A, B, C, D. So did you get my question? If you have if you have say this model, and there is less than or equal to 50% machines are available. Imagine 4 machines are there. 4 machines were there, and two got shut down, two shut down, two available. So even though two are available, still still it is read only. Why? What is the reason behind more than 50%, or in other words, majority? Anyone? Maybe the leader keeps changing based on ping response. Mhm. Why is the criteria high availability is good, a good answer, but why? It's actually not highly available. If you see, we had still have two available, still it's not available for writing. All right, the answer lies in this diagram. Answer lies in this diagram. It took me a fair amount of time to actually uh, give out this answer, because everybody kept on saying that if it is gossip protocol, then it is 50% majority, and nobody gave a good reason. So here is a clear, and I'll try to help you understand. So imagine that you had two data center, data 1, data 2. In data 1, there are 3 machines. In data 2 also there are 3 machines. Okay. Now let us say that there was no majority rule. Okay, instead let's say there is a rule that whatever machines are available as of now, amongst these machines will vote, and whosoever will get maximum vote will become the leader. There is no constraint of majority. In case you have four nodes or six nodes, if in case in this diagram you can see six nodes, even if three machines vote for somebody, he will become the leader. Okay, now, okay, so even if there are only three machines available for voting and they vote for somebody, somebody gets highest vote, that guy becomes the leader. Let's say that is the rule. What will happen? What will exactly happen? Imagine that this connectivity between these two data center got cut. Okay, the connectivity got down. Now what will happen is both of these nodes, both of these individual data centers, they will choose their own leader, because if there is no constraint on 50 more than 50% or majority vote, what will happen is there will be two leaders. Both leaders will be accepting right request from their corresponding data centers, and effectively your data is damaged, your data is inconsistent. It is not eventually consistent, it is inconsistent. All right, makes sense to you? This is very important. If you have any questions, you should ask right away. The idea was to select a leader by the majority vote. People vote for everybody, and whosoever is the leader, whosoever gets the highest vote becomes the leader. So do you have any questions on this? Is it clear to you? No? Yes, that is correct. Now, Murugan's question is 50%, why it is 50%, not 75%? Anybody can answer? Or 25%? Can anybody answer that? If we have only two machines, then one can never be there. You have to have total two machines always for the voting. In case one goes down, there will be no leader. Okay. Sam's question is, if there are two leaders, how will data become inconsistent? Is that your question, Sam? Now, imagine that there are two databases. Okay. So they were in the beginning the same data. There was only single database in the beginning. After some time, both got a copy of data and both declared themselves as leader. Some of the users are writing to one, some of the users are writing to another. Now what will happen? On one node it was said that delete this particular record, while on another node it was said get me the details of this particular record. So if if you notice that the centralized sense of data, the correctness of data is gone. They in fact they became the two separate record. In one it does not exist, in another it exists. Okay, so which one should we honor as data? The left one or the right one? Got the idea? All right. Now, yeah. So Murugan, anybody can anybody answer Murugan? To provide balancing between system availability and load balancing. Okay, okay. So here, let's say availability only. How does question is that why more than 50%? Why not more than 75% or 10% or 25%? Why it is that we require more than 50% votes? Okay. Now let me ask Morgan a simple question. Out of a pizza, how many pieces can be bigger than 50%? Out of a pizza, out of a pizza, how if you cut it, how many pieces can be there bigger than 50%? How many pieces can be if you cut it? How many pieces will be there when you cut it exactly into half? There'll be two pieces, right? If you cut it exactly in the half, if you cut it slightly bigger than half, then there could be only one piece which is bigger than biggest, right? There could be one piece with the size of slightly bigger than 50%, right? Therefore, and that's exactly the reasoning used here. When the network gets partitioned, it's like pizza getting cut. Okay. Now, to make sure that there is only one leader, we made this rule that if the partition of the network which has more than 50% node becomes the leader, can only elect the leader. That means the pizza size where the bigger part is there, only that side can be a leader. This ensures that there is always one leader. Make sense? Is it clear to everyone now? This is a very important point to understand. All right, because this is a very common phenomena when you run a distributed system. Some of the systems are in one data node, some are in another. So partitioning as in disconnection between the node, may convert the conversion from one big network into isolated networks is very much possible. Okay. Yes, that is correct. Shyam's word is smallest majority is possible when it is slightly bigger than 50%. Slightly bigger. And since in our case we are talking about numbers, discrete numbers, we say that one more than 50% because one is a very smallest unit of this. All right. So an ensemble of 10 nodes can tolerate how much of shutdown? Quickly, this we have talked already. Yeah, perfect. That's correct. So it can only tolerate the shutdown of 4 nodes. There are 10 nodes. You keep on shutting down. So the minimum number of nodes required for having a master is 6. So you can shut down 4 nodes and still everything will be perfectly okay. There will be a writer always. Okay. All right. Let's take a quick break of 10 minutes. What if it's 50 nodes? Okay. Morgan's question is, what if it's 50 nodes? So you tell me, somebody else can answer? Yes. To 24 shutdown, you need to have at least 26. You can shut down 24 and still there will be a master. That's correct, Chandra. Thank you. And yeah, yeah, you can think of it that way. But if it's odd, then n by 2 means 3 by 2 is 1. Okay, cool. So uh, I'll be back in like 10 minutes. And then we can continue our discussions. Okay. Hi, I'm back. Should we start now? All right. So, all right. So let's start. Only Shyam is available. Everybody else? Chandra, Morgan, Santosh. Should we start now? Okay. Yeah. Yeah. The 50%. Yeah. So in case of four people, I need at least three people to be available. Yeah. So Shyam is saying something. Amazon and other. Uh, yeah. So only Chandra is not available. So we are 50% more than. Then we can start. We are majority. So yeah. So yes. In case of, if you guys have read that paper which we talked long back from Google, for example, so they have something called Google File System on the lines of HDFS. Similarly, they have HBase similar to HBase. They have Bigtable and MapReduce. There is one more thing called Chubby service. They call it Chubby service. That Chubby service is essentially Chubby service is essentially the zookeeper. So Google uses it. At Amazon, we did not have this kind of a sophisticated machine system. Instead, we had developed some sort of libraries which were not up to the mark. Now they had we were trying to do the coordination using using the central NoSQL databases. Okay. Mm, yeah. So at Amazon, I'm not aware of such a service, but at the we did have one configuration service which looked like Zookeeper, but not that much available. All right. So this configuration service was the one where every application used to store the configuration so that if the application runs on the cluster anywhere, they will all retrieve this settings from this central service. Okay, but then that was not like true Zookeeper. This configuration to service looked like just like key value pair, the registry edit kind of thing, which is basically the tree structure. But the philosophy was not really like a zookeeper where the consistency and coordination is the only agenda. Okay, so yeah. So there are few guarantees. One is guarantee sequential consistency. Update from one particular client or update applied in the order. Atomicity, either update should fail or succeed. Single system image is a client will see the same view, okay, and the new server will not accept the connection until it has caught up. Okay. So durability, the data is actually first persisted and then loaded into the memory. Okay. Timeliness, rather than allow a client to see the very old data, the server will shut down. In case the data is very old, the server actually shuts down. Okay. Sessions, a client has a list of servers in the assemble. Okay. So basically it every user who is connecting to Zookeeper master, Zookeeper as an ensemble, there is no master as a Zookeeper ensemble. They all maintain, all the clients who contact the ensemble, they all maintain the session. So in the beginning, the client get the list of servers in the ensemble. It keeps on trying to connect until from one end to another until the try is successful. Okay. Once the it has found a server, it creates a new connection, and and as soon as the connection is created, the server has a new session allocated for each client. So session always is on the both sides of the wire, client side as well as server side. Even in your browser, there is a session on the browser side and a session on the server side, right? Now, every session has got a time period, meaning if the client does not respond within few seconds, the session will get deleted, and the user, it will consider the user has logged out. Okay, this is good in case there is a network disconnectivity from client side. Okay, in case there is a network disconnectivity from client side, the connection is closed. There is a network disconnectivity, so the session will be deleted and all the ephemeral nodes that were created will just disappear. Okay, so which also means in case a client want to maintain the session, it will have to keep sending the pings called heartbeat. The client need to keep sending the heartbeat to the server saying, I'm alive, I'm alive, I'm awake, and so on. All right. The client library, the user, you as a user, you will not have to think in terms of the heartbeat. The way our Zookeeper is still running, and it's basically we did not have to do anything. Is the duty of this client, which is in the back end, is sending these heartbeats. Okay, the client library keeps on doing that. It's a part of the mechanics of the client library. Failover is handled by the client. The client library tries to handle as much as possible the failover, meaning one master got shut down, election has happened, somebody else has become master. Now this client, if this client has to talk to master, then automatically the client library will keep on switching. It will send a ping and will check. That ping will also inform that this is the master now, and these are the slaves, or these are the leaders and these are the followers. And after this information, it will basically update its client information saying this connection is actually now open to the new server. So that way, most of the complexity of all of this is handled by the client library layer. All right. Also, even though the client library layer provides you a brilliant amount of abstraction, meaning hiding the stuff from you that it has to send heartbeats every now and then and it has to keep updating which who is the current leader and so on, and how many nodes are down, all of that information is available for the client library. Okay. Now, given this fact that client library tries to hide everything from you does not mean that you don't care. Okay, because if in the transit, say it connected to server 1, and after server 1 there was a re-election, so server 1 uh, step down from the leader position. Now, if and there will be 200 milliseconds between this point and the server getting elected. That means that for close to 200 or maybe more amount of time, the your client is disconnected from the ensemble. In this duration, if you try to write something or read something, it will keep on throwing the error saying it's not connected. So you cannot be agnostic about not knowing what's going on with the server. Okay. Now, question from Shyam is that how does the leader voting happen in reality? Okay. In reality, how does it happen is all these nodes, all these nodes basically mm, all these nodes basically form the opinion about other nodes. By pinging the other nodes, every node forms an opinion saying this node is down, this node is down, this node is up, this node is down, and this node is faster, this node took this much time. After this, they will reconcile and compare these results. And whosoever wins out of this comparison, then that node will become the leader. Okay. Now, this is how generally the H-based region servers work. So imagine that these many are the region servers, and these are your H-based clients. Okay, or these many are your data nodes, or task tracker or data nodes. These are your task tracker, for example, and on the right hand side are the clients who want to talk to the data nodes. Now, imagine that HDFS was using Zookeeper. So what will happen is, or you can think of, how should I say, not Task Tracker is bad example. So you have launched a very highly available service, very highly available service, and there are 50 servers. 50 servers are there, out of which, no matter what happens, you should be able to cater to the end user's request. Now, this client library, these client, the users, if they start maintaining all these 50 servers information and keep on tracking which one is down, which one is up, it will be too much of a headache. Instead, what they have done is this zookeeper is the one which acts as an intermediary. Every server tells zookeeper that create one ephemeral node in this folder, and every client connects to zookeeper and says give me all the ephemeral nodes in this folder. Ephemeral node is the node which disappears the when the client disappears. So both left hand side and right hand side both are acting like a client to the zookeeper. This left hand side clients are creating their ephemeral nodes under a folder, and right hand side the users, the actual users of this server, are talking to zookeeper and asking, can you give me the listing of all the servers I mean, can you give me the listing of all the nodes under a particular folder? And based on that, it is client is deciding that these are the servers which are available as of now. Okay, so it's like all these servers came up as we started them. They gave their attendance to zookeeper, and then each of them kept on telling zookeeper that hey, I'm up, if something comes up, let them know that I am up. And these guys go to zookeeper and say that can you tell me which nodes are up? It tells you that hey, this is the folder containing ephemeral nodes created for all of these nodes, which these nodes will essentially represent that these servers are up. And this way, it provides you a humongously available service. All right. Very correct. Thank you, Murugan. Yeah. So in case of Zoo or any of such services, be it MongoDB or any other which follow the gossip protocol, there will be active TCP connections as well as the network traffic. Okay. And this will have an impact. It is a cost, it's a good enough cost to pay for this thing. Okay. But sometimes that cost becomes too high to pay. Okay. Right. N- Now, on the same lines, so imagine that, let's go ahead with this example. So this is our zookeeper. On the left hand side is server. On the right hand side are clients. Basically, both are clients to zookeeper, but in general paradigm, this is how we think. So HBase region server is this side, and HBase end user is this side. So as soon as they are connected, this guy said under the servers list, ls/servers, ls/servers. There are no servers right now. So let me just clean it up a little bit. So this is our one server and we are creating one client. So is this clear to everyone? Okay. Now this is the client. It comes and says which are the servers available. On the left hand side, this guy comes up and says create -s, and under servers, not as, it says ephemeral node. Create -e under servers, and let's say we give the to node name to say one, this is the IP address. Okay, say hadoop1.nobigdata.com. This is one server. Okay, and we just put a data here called up. Right now, similarly, another machine comes up. They connect to, let me just log in. So now let's say we have, okay, it also says that create /servers slash Hadoop 6.nobigdata.com, and it says -e means ephemeral node. So is everybody with me, or is the font visible? So one server is Hadoop one. It created its folder called Hadoop one. That's all. And second one also created some. Up is just any data we have put. We just one string representing this. Now if you say ls/servers, you see, oh, there are two servers. This is the client. This is the, let's say this guy is the client, and it says, oh, there are two servers. Nice. Let's just connect to some any of these. Okay. And this client will get this information that these are the region servers available right now. Okay. Now the moment The let's say first one is disconnected. Okay, first one is disconnected. After some time, after some time, this node which was done by Hadoop 1 will disappear by itself. Okay, it takes a little bit of time. Now the Murugan has created one node of itself, so I know that Murugan is also available, right? So I think you have created Murugan, that one. So similarly, all the nodes parallelly can say that I'm up, and now Hadoop 1 automatically disappeared after some time because this got disconnected for whatever reason, right? So you can see that Hadoop 1 is no longer there, only Muru and Hadoop 6 is there. Okay. So this is one of the roles being played by Zookeeper, and the sequential one, in which every time you create a node, it creates a, say, under servers, or let's say we create a folder. Here we say create mail IDs. Okay, we call create mail IDs for ID generation. All right. Now let's say it was we created this. Now every time we say create minus s and say mail IDs, and we just put some data, okay, it will create a sequentially new ID. You can see that we have created so many IDs. Now, can you tell me where exactly such a system be useful? Anyone? Can you tell me where exactly this will be useful? This would be useful in, so we are every time we are creating an ID, it is getting a new name. If you want to apply a prefix here, we say that this is my prefix. So by default, it will be adding that prefix, but continuing from the same folder name. Okay. So each parent node has got an ID on the basis, and in this, no matter what prefix you add, it will continue the node IDs. So here we have got 13, 12. Yeah. So these are sequential IDs starting from 1, 2, 3, 4, 5, 6, and so on. Okay, they look random because it's a lexical sorting. Right. So identity column of the table's duty is what is being played by this tool. Okay, that's good. Specifically for if you're building a huge task tracker, issue tracker, or a help desk, this can be very useful. Okay, this can be very, very useful. All right. Now that's pretty much about. There are many things you can do, and these are the few examples of what you do with the basically with the zookeeper. Okay. So now I want to take up the next session. All right. Okay. So yeah. So now we want to discuss something called scoop. Right. So Uzi was a great coordination service. It can be used for ID generation, and it can be used for load balancing. It can be used for high availability, and it can also be used as central configuration management or a locking service. In Java and other programming language, the synchronous things like lock and synchronized keywords, they provide synchronization. In case of distributedness, you cannot have that kind of syntax, and that's why you require a server to do that. Yeah, Uzi is the workflow management. Well, Uzi is like Apache Ant. Okay. All right. So let's start with Scoop. Okay. So in case you have to import the data from relational database into HDFS, Hive, HBase, you can use Scoop. Scoop does a very good job of bringing the data from relational database to HBase, file system, and Hive, as well as it takes the data from all these three tools to back to the relational database. Okay. So it's an open source tool which extracts data from a structured data store into Hadoop for further processing. It can also move data from database to HBase, and it can also export data from here back to the relational database. Now, it's a great extension framework for developing new connectors, and that is the reason why it is so popular. I mean, it has the support for all databases. The general syntax of Scoop is pretty simple. Okay, the general syntax of Scoop is very straightforward. So you can say Scoop help, and it will display all the details. You can see this. So Santoshi's question is it like pull data into HBase, run the queries for data messaging, and pull data back to RDBMS? So it goes a little more deeper than that. Generally, what you do is say your data is distributed across hundreds of your web servers. You pull all of that data into HDFS, that is unstructured. In case you have some relational database, say your relational database contained the lot of movies. Okay, this user likes this movie. Say there were a very huge table available in relational database with this information. Okay, now what you wanted to do was you wanted to apply really complex algorithm on this data. Okay, and generate recommendations. Now to run those complex algorithms, your relational database may not suffice because you might have to execute it parallelly on multiple machines. Okay, so what you do is you first take this whole data from RDBMS, push it to Hive, or push it to HBase, or push it to HDFS. Once that is done, you run things like Apache Spark, or you run things like MLlib, or you run things like Apache Mahout to generate the recommendation. Now, this generated recommendation is the one which you will take back from HDFS to your web server, or back from HDFS to your database table. Okay. Why did we do this? Because this kind of data handling was not possible in RDBMS. All right, good. Anybody else having the same question? All right, so here are the various commands of Scoop. It provides you the import and export. Now, it provides you the connector for MySQL, Postgres, or Oracle, SQL Server, DB2, and generic JDBC connector, which effectively means that you can download the data from HDFS into any of the SQL databases, as well as from SQL database into the HDFS or Hive or HBase. Okay. So first of all, before we start, let's create what we want to do in the first set is we want to import data from MySQL into into HDFS. Let's do that first. We want to bring data from our MySQL database to our file system. Okay, HDFS. For that, what we do is first we create a dummy data. We create dummy database like this. And also note, very importantly, there are few things you should note. These things might work great i- on local one, but note that Scoop is a distributed service. When you import data into Scoop, it is going to multiple machines are going to talk to your database and get the data, which means that your machine, even though you are launching from Hadoop 1, your database will be installed on Hadoop 1 generally. And in case you have 10 Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, Hadoop 5 up to 10, all of these databases might contact your MySQL, which means you have to allow all of these 10 machines in your security settings. Okay, that is why these commands, and this was the reason why uh, something which runs very well on the virtual machine may not run on the on the real cluster. So that's the difference. These are the small things which make a very huge difference when it comes to the real cluster and the virtual machine. So people just create the database locally in the virtual machine and they feel happy that wow, we are able to import. But truth is, since MySQL is going to get hit by so many other data nodes, then that it has to provide the permissions such that all the data nodes can talk to MySQL. Okay, so let's go here and let me just create this database. It says database already exists. So what we do is we just drop the database. Okay, we have deleted that. Now let's create this database first. We are creating this database in MySQL, the normal usual RDBMS database. And then we give the privileges so that now all the users can access, all the machines, Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, can access this database. Okay. Now next thing is we created a dummy table in this. We'll create this dummy table. Okay. We'll just say use default. Show. Okay, we have to use the same database. Scoop ex3. Good. The database is used and the table is created. Now we inserted these values into widget. So this is the data which we have just created. Okay, this is the data which we have just created. All right, this is the table in our MySQL database that we have just created. Now let's take it to the next level. Now let's try to import it to HDFS. So all we do is scoop, import, connect to this particular uh, MySQL server. This is the syntax of specifying MySQL driver URL. Okay, so if you are importing from MS SQL, you provide a different URL and it will basically connect to that URL. Okay, now let's say we connect it this way, not this. Let's go here and we say import connect to Hadoop 1, no big data ex3, and table is this, and username password is that. Now it will try to do import, and in case the table exists, it will fail. Okay, it's basically importing the data now. All right, you can see that it is again running the MapReduce job to import the data. Okay, yeah. So why? Because in case your generally your databases are very well beefed up machines, and you if you want to speed up the process. Second is the IO consumptions become really nice, really fast. So okay, let me describe it this way. If you are accessing data from multiple machines, there are high chances that it will become faster as compared to the single machine. Okay, so it has imported the data. Okay, it has imported the data, and if we say Hadoop fs minus ls, there should be a file called widgets. There is a widget file, and this is created today. Widgets directory. Okay, now we can say widgets, and under that you can see the part that restores the that enforces the fact that it is basically a. Now you can see this. So here it has imported our data by comma separated values. Make sense? Also notice that here there'll be widget.java. Widget.java is the one which becomes your good mapping between, if you see, it becomes your mapping. Okay, like it generates a code which can be used for other again and again. If you have to process, you can use widget.java for importing the data. It generates basically generates the what do you call a sort of an ORM class. All right, similarly, now next is first one was copying to HDFS. Now copying to HDFS was okay, but if you have to import to Hive, now importing to Hive was okay, as long as we don't have to keep on typing that create table command. Okay, so Hive Scoop helps you in that. Scoop also creates a Hive table, and then you can load the data. So you can say that create the Hive table based on this. Okay, it'll basically create the Hive table for you. Okay, so you say that here is my database table. Based on this table, please create, based on this database table, please create a Hive table. Okay, instead of you typing by yourself that these are 100 columns, you type them and you specify the data structure of every field. Let Scoop do it for you. So that saves a lot of effort. It just looks up in Hive and it basically creates a Hive table. So let's see what happens. So we go here and say this. Scoop creates the table for our data, this particular database, and for this table. Does it give an error? It should ideally give an error. Oh, the database is not there already. So describe, describe, what is the table name? The table name is widgets, because that's the same table name. Whatever we have imported, the name will remain same. Yeah. So you can select star from widgets. So the data was already there. A better thing will be drop table and we say widgets and use this command to import again. What do you say? So let's import it again. We have deleted the table. Now it should come here. Select star widgets. Now it should be empty. See, it's empty now. All right. The only problem I see is only problem I see is that this file which we have just uploaded, this file Hadoop fs minus ls widgets would have been deleted because it creates a managed table. Oh, it's there. Good. Yeah. So Santosh's question is that, so what we did was I did a little bit like a magician here. I did not do it slowly. What I did was on the left hand side, I ran import create table. It created the table. And after dropping the table, I created the table from scoop. And then I did the select star from widgets. Okay. Now we can say describe widgets. Now the data is not there in this table. Okay. And we have, so this is our table in Hive. This is our table in Hive. Here in HDFS, we have widgets folder containing our data. We can import this data manually. Okay. So we did 3 steps. We took 3 steps. We can say load data in path this into table called widgets. So this file will be moved to that location. Now select star from widgets and you can see we have got the data. Okay, so we took 3 steps. First one was imported data to HDFS. Second one was created hive table. Third one was these were done using a scoop. Scoop imported this. Scoop created this. And third one was using Hive, we loaded number 1 into number 2. Perfect. These are the 3 steps we took just now. All right. In other words, we imported that file into HDFS. Next was created table, Hive table, then loaded that data which we copied earlier to HDFS into our widget. Make sense to you? Now, these are the 3 steps. If you want to do it in a single step, this would be the right approach. Okay, so let's drop this table again. We say drop table widgets. And now if you say select star from widgets, there is nothing right now. What you can do now is from here in the command line, we take this and say import. Okay, what does it say? What does it say? It says that this widget already exists. So we need to drop the folder as well. Okay, so we need to say Hadoop fs minus rmr widgets. The file in HDFS exists while Hive did that. So yes, Murugan, create Hive table will only create the table structure. It will not import the data. If you want to import the data, you can say a scoop import this, and also mention Hive import. Okay, you can see that Hive import. All right. Now we say like this, let it now import the data. It will do both the things in a single shot now. There's only one split and it's doing something. All right. So today there was no problem of connectivity. It is only the 10 o'clock which is the problem. All right. Select star from widgets. All right. So it has been imported. Perfect. Earlier when we said select star from widgets, it gave us table not found. Yep. That's sort of a danger zone, yeah. And the tragedy is I can't even explain to the service provider that this is the problem. Okay. Now, coming back to his question, let's see what kind of table it has created. Okay. That will answer your question. So, Chandra, you can see this is, let me say, describe formatted is the better way to use. It says that it is a managed table. Okay. Now, let's drop this table. Drop table. What is that? So also notice that when we imported, so Hadoop fs minus ls widgets. Okay, there is no such directory called widgets. Chandra, are you with me? So whatever directory we created earlier has been moved to Hadoop's folder. Okay, and let's see where did it was it moved. It has been moved to the warehouse. Now you can say like this, you can say Hadoop, right? It is there now. If we drop this table, drop table widgets, okay, and now try this. There is no such file and directory. Okay, yeah, we can ask them to join the course. And okay. All right. So this is how we were able to do the import. On the similar line, we can also import into HBase. It is just that my HBase is not healthy. While my Zookeeper is reporting that it's working fine, it is just that this HBase is bothering me. Yeah. So Zookeeper server is there, and I think Zookeeper is only running on one computer. One region server is up. All three are up. Now let's try to import this data, same data, into HBase table. We are saying import data, and here minus minus, the way we said Hive table, we are saying HBase table. The other difference is we have, because the while creating a table, we need to specify a column family. Therefore, we are specifying manually this extra information called this is my database table and this is my column family. Okay, okay. I just hope that HBase, there's something wrong with this HBase. I'll have a look at it. All right. So yeah, we were able to dump it in HBase. Now let's have a look at it. So it says that HBase create table, which means a widget will be created, and we can say scan widgets. Scan widgets. We have to put it in single quotes actually. So it says that, so what was the table name? Yeah, my HBase table is the HBase table name. Okay. Scan my HBase table. Now you can see that in HBase, if you remember, we talked about row IDs. So this is the first row containing row 0 and the column name. Column name is column family CF1, the same thing what we had earlier. So how does our table look like? Not like this. Let me say MySQL, and we say select star from widget. Okay, so you have to say use scoop ex3 and then select star from widget. This is our table from database. It has widget name, pricing, design date, ID, and all. And so here the the first column is this. This is the first row. This is the first row. All the column except for IDs. Okay. Now here the ID column by default goes to become the row ID. Okay. That has become the row ID by default. It's the name of that column called ID. Okay. Similarly, for the second one, the ID is 2. So the ID has become 2 here. Row that ID has become row key, and so on. You can see that? And for each value, yes, we did declare here, if you see, we said column family is CF1. We said column family is CF1. All right. Yeah, column names are from the main one. Whatever column names are here, it automatically picked them and put it there. Okay, that saves a lot of headache of translation. If you want to specify few columns, very good. So what you can do is you can basically say things like scoop, and if you look at the help, if you say help import, okay, under here you can say which all column you want. I'll show you that. Okay. The, also, if you want to override the default row key, you can change the name of the. If you have a column which is something like XYZ and you want that to become the row key, you will mention XYZ here. Okay. Now column family and there is something called columns. Only few columns you want. In those case, that is a general one. I'll show you that. Connection, password file, append, boundary, and number of mappers, how many. So sometimes you have to specify number of mappers and all to make it far more performant. Okay, all right, don't no worries. So here there is a column name. Yeah, there are actually column names. You can specify those column names. Bye bye, Chandra. I had actually used the number of columns. Basically, you comma separate and give it a list that these are the columns I'm looking for. Okay. And it picks up those columns. Yeah, here. You can see that. This one. You see? So this is that column names. Okay. And also because this data is generally fairly big, and if you're copying the data, you're consuming too much, you can actually do the deletion parallelly. Okay. All right, so that way you can import into HBase, and now sometimes you have to take it back from Hive to MySQL. Okay, so suppose we have a file like this. We have got a file like this. We already, I think, have this file Hadoop fs sales.log. And just a second. So here is my, not here. Let's say I'm opening a Hive. So now I have four command prompts, one for HDFS, one for dedicated Hive, other for MySQL, and first one for HBase. Okay, so what you do is, let's say I think I have already a table called sales. So exactly in the same way, if you want to take data from uh, big data side to the relational side, you can use, instead of export, you can use import, and little bit different mechanics. Okay, so now let's say select star from sales should be there. right? So sales table is there in my Hive. What do I want to do is I want to move this data from here to basically to the normal one, to the MySQL. Okay, so let me go to MySQL and drop the table from here, because in the from the last session there will be some sales table. Good. Sales table does not exist right now because we had deleted the database. Now what do we do is we simply say scoop export. Note that keyword export. Import, the way you can remember is we always talk in terms of big data. So we are on the big data side. Anything we are taking from relational is import, giving out to relational is export. Okay. So all we do is we say export this particular table over there. And what does it say? It says sales does not exist. All right, this is not good. Yeah, this is some catch. You have to create table by yourself. Okay. I think I think there would be some way. Scoop help export. So there will be connect, skip username, variable, clear, direct, stays, update table, validate, validation, input, file, bind, class name, escape, fields terminated by SQL delimiters. Okay, bind directories are map column names. Okay, it's not there. It does not let you create the table automatically. All right, that's a news to me. So first you need to create an empty table in the MySQL. Now select star from sales. Looks like this. This is empty, and now we can import the data. All right. All right. Now you can see that. Let me make few notes. Hadoop export create table. All right. Now, if we go back into our SQL prompt and say select star from sales, it has imported the data from Hive. All right. Sounds good. You can try by yourself all of these commands. Trust me, it is going to give you good confidence. Okay. With the different different table names and different database name in SQL, try all these commands. All right. Now, a bit about Flume. Flume essentially helps you transferring data from unstructured sources to HDFS. Okay. The overall objective of Flume is taking data from all kinds of weird sources to HDFS. Okay. And it gives you such a powerful pipelining mechanism of flowing the files into HDFS and flowing any kind of data and converting that into HDFS. You can think of that downloading Twitter data using Flume is actually quite performant. The overall idea with Flume again is the distributed. Flume does all of this in a distributed manner. Okay, you install various kinds of agents on various machines, and they keep on flowing the data parallelly to HDFS folder. Okay, it's a reliable, distributed, and available system. All these three keywords are very important for efficiently collecting and aggregating and moving large data from many different sources to a central store. Okay, so that is little bit about Flume. Okay, basically Flume is made up of three things: source, sink, and channel. Okay, source is the producer of the data. Channel is the one which is intermediary memory pipe, and sink is the one who eats the data from the channel. Those who are coming from producer consumer background, they can think of this way: source is the producer, and sink is the consumer, and channel is the intermediary pipe for making the communication between source and sink really fast. Okay, so imagine this: source might be generating data very frequently, while sink will be consuming data at a slow pace but bigger data at one shot. For example, if sink is writing to the disk, sink will be doing it, taking too much time to write, but it will write a very huge chunk. It will write, say, 128 MB in a single shot, while source will be generating few bytes per milliseconds. Oh, audio issues started. Yikes. All right. Okay. So yeah. So basically, uh, to make the communication between source and sink, this tank in between is created called channel. On one end, source keeps on writing at its own pace, while sink keeps on consuming at its own pace. So the channel uh, behaves like an intermediary. Okay, channel can be disk supported, can be in memory, can be on the basis of some existing SQSQ or Kafka, of whatever possible you can use. Make channel that way. Channel can be a database. Okay, so I mean, in next session we will show you how to create the whole mechanism using Flume. Okay, and then we will go into Spark and Uzi, and then we will do the further detailing of uh, the comparison of various databases. So we'll talk about now. We have Uzi, Mahat, Uzi, and Spark. These are the three main components left, along with Flume, Uzi, Mahat, and Spark. These are the four components left now. Okay, we can talk about these in the next session. All right. Okay. So in case you are preparing for Hortonworks, so Murugan's question is that does these content sufficient to get big data certificate? Ideally, this whole course is far more bigger than what Hortonworks certificate is about. Whatever Hortonworks certificate was there is actually uh, first four sessions plus a little bit half of our pig session and hive session. Okay. Now uh, basically, the course which we have created is based on the industry need, okay, an understanding of all the different kind of components. Okay. Now, if you are planning for Hortonworks, other than our content, to brush up things, you should try the definitive guide of Hadoop. Okay, the definitive guide of Hadoop, because that's written by one of the Hot and Works guys, or I think it's Cloudera guy. I don't know. Okay, but that book is really good. I like that book. Okay. All right, then we will continue from here in the next session. And there are so many assignments pending now for you. Okay, and basically try to do both the things. Try to run HBase all the queries by yourself. Also, the whole scoop flow we actually did quite much demo in scoop. We okay. Good, Santosh. So try using Hadoop streaming. It's good enough to work upon. Okay, it'll be good. Some of my students have actually finished. They have launched their GitHub project, and it's actually pretty good. Yeah. In what terms do you need guidance with respect to Python and MR? Actually, it's not worth it. This PyDoop is pretty old and is not supported. You will get stuck in midway. You don't require the installation. You can go to Hadoop streaming.jar and start using it. Okay, I'll sh I'll show you that. If you remember our first session for 1 to 3 session, I think. Yeah, I'll show you here. So just write your program. Where is our? So I think we should include that as part of our session now. Give me a second. I'll show you. Actually, there is one person in my. I'll just hide the screen for a second. Okay, I'll just hide for the screen for a second. Okay, all right. So this is the example code. I do not want you to just copy it. Okay. He has basically, I would actually strongly recommend to you that you take any of these code and not don't take this code, but launch your own GitHub repository with the no big data name. And under this, basically make sure that you are putting nobigdata.com somewhere so that we also get a back reference link. And okay, so this way you will be able to see the some assignment, but don't try to copy and cheat here, because if you see that you can write mapper.py this way, you can say yield this, yield that. This is like saying give out map and reduce. All right, and similarly you can write reducer. Okay, and once you have written both of them, you can utilize a command like this here. If you remember, instead of saying mycmd.sh, you will say mycmd my mapper.py, and this one you can say my reducer.py. Okay, that's all. Okay, and make sure here you mention both the files in the file. Here you can say minus files, and you can say like this. Okay, and this, wherever you are launching this command Hadoop, in the same folder these two files should be there. Okay, it will be easy if you just copy paste it into one another cell file and keep on executing that file. Okay, also make sure your your my mapper and my reducer is ch mode plus x my mapper dot py and my reducer dot py before you launch. Yes, that's correct, Morgan. Okay, so before you launch this, th- do this so that you'll not face any challenge. All right. Okay, so if you know Python, you write these my mapper, my reducer. In mapper and reducer, while giving out the output, use the command called yield. And after that, you save both the files. Do chmod plus x. Once that is done, go to the same folder, copy. Go to the same folder where you have done. Say you have done on Hadoop one and some folder, and then you can do. Yeah. So good part is that any of the Python code you write will run without Hadoop. Okay, that is the beauty of the Python code. Even if instead of yield, even if you are using print, still it will work. Okay, so basically your Python code remains pure Python. Okay, the way we used sed instead all of these commands together, like same thing could be achieved without Hadoop also, basically by pipelining. Okay, so try that. It will be a good experience for you. Okay, and also make sure that this file contains user bin python at the top. Okay, because here we are not telling Hadoop that execute Python. Hadoop or the Unix is automatically figuring out how to execute this Python command. Okay, so we talked about few things. You create these two files, mapper.py and reducer.py on say Hadoop one in your own folder. After saving both of them, in both of them, if you want to spit out key value pairs or whatever you want to do is you take the input from standard input and give out on the standard output. And once you have done that, you basically chmod both of them, and and also make sure in the first line of each of these files you have mentioned hash exclamation slash user slash bin python. Okay, this is the location of Python program. And so, and before handing over to Hadoop, try running it locally by giving it by giving the input to this like this. You can give cat file pipe dot mymapper dot python. Okay, so basically you can operate on this way. Okay, so this way you can, before giving it out to Hadoop and saying Hadoop is not working, you can test out your mapper and reducer independently. And once that is done, you can basically say cat input and then give it to mapper, and then sort the data which is coming out from mapper, and just give me a second. All right, this will give you the exact result. Instead of this is cat not. Okay, this will give you exact result what Hadoop will do without Hadoop. Okay, you can test it. Okay, so if this is working, then you are ready to put it on Hadoop, and then this way, this command which we are talking, you can do that way. Okay, and yeah, and this chat log is available in your history in your documents. Okay, so you can pick up the chat log from there. All right, and if you have any doubts, just drop me an email. I will generally provide you a very quick hint to solve your problem. I'll not provide a big answer. Okay, and yeah, I'll try to answer this. Okay, or you drop on the forum so that people can do that. All right, all right then. See you tomorrow. Bye bye. You too. Bye.